If someone points out to you that your pet theory of the universe is in disagreement with Maxwell's equations, then so much the worse for Maxwell's equations. If it is found to be contradicted by observation, well, these experimentalists do bungle things sometimes. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse into deepest humiliation. Sir Arthur Stanley Eddington. Entropy, sometimes called disorder, is a measure of the number of random ways a system can be arranged. Disorder is all around us. From the waves of the ocean, to cars on the highway, to dust in the air, disorder is fundamental. Whatever you call it, messiness, disorder, randomness, you're intimately acquainted with it. Whether it's the cup you broke on your rush out the door, or the dice roll that won you a cool grand, you have disorder in the form of entropy and the second law of thermodynamics to thank for it.
I've seen so much chaos, it's ridiculous.
Each of these bags has relatively low entropy. The only way in which this bag can be internally arranged to look as it does is to have only pepper grains, with each pepper piece next to another bit of pepper. Similarly, the salt bag contains only salt, with each bit of salt neighbored by another grain of salt. When mixed, the new bag of both salt and pepper has greater entropy than the original bags. If I wanted to specify the exact number of possible arrangements this bag could be in, I would have a lot of counting on my hands. Of course, if the entropy is low, it takes me no time at all. Let's spice things up a little more, shall we? Adding these beans to the system is akin to adding another dimension, not of space or time. Think of it rather as another way for the overall arrangement to vary. Again, we've increased the entropy of the system. In fact, we've increased the entropy by more than just the sum of all the different food particles in the bag. How did we achieve this feat? By adding another dimension, we added another way for the particles to be related. Rather than just pepper next to pepper or salt, we now have pepper next to pepper, or next to salt, or next to the beans. Specifying that list is far longer. In fact, in this way, the idea of entropy can be extended to the domain of any type of information. The longer the minimum length of a message necessary to describe a system, the more entropy it has. Excuse me, let me eliminate that entropy. The second law of thermodynamics tells us that the entropy of the universe must always increase. Even local decreases in entropy must be offset by a greater systemic decrease in entropy elsewhere. In the case of my entropy minimizing device, the energy used to power it comes from a nuclear power plant, splitting one atom into two, as done during nuclear fission, increases the number of possible states of the reactor by increasing the number of different atoms, leading to an increase in entropy. The second law also implies that heat flows from a hot object to a cooler one, as when ice melts into water. Suppose that these bottle caps represented the atoms in an ice cube. They form a nice, neat arrangement. All we need to describe all the possible arrangements of the bottle caps is to say, every bottle cap has 8 neighbors which form a square around it up to the edges of the tray. If I switch 2 bottle caps, I still have the same description. Wiggle 1 bottle cap out of place, and I've ruined the pattern. If I wanted, I could specify the tray size and easily be able to recreate the pattern anytime I wanted. Now, watch what happens when I add some energy by shaking it. Shaking the tray is like adding heat to an ice cube, melting it and causing it to form liquid water. From looking at it, we might guess that the disorder has increased. More precisely, we find that the number of possible rearrangements of bottle caps that produce a statistically similar pattern, one that looks messy to our eyes, is much larger than the different possible arrangements that form the grid pattern. Wiggle 1 bottle cap from its current position, and the whole still looks messy to us. Shuffle a few caps around, still it looks all the same. The entropy is greater when the caps are random than when they form a grid. Clearly, melting ice or shaking bottle caps on cookie sheets increases entropy with the help of energy.